So this is another lesson on measurement 1. It is our second lesson out of the 150 lessons I promised you. So measurement 1, whenever you see a lesson indicated as measurement 1, simply it means measurement 2 is still on the way. And in that case, measurement 2 is in form 2. So today I want to take you through the introduction of measurement 1 as others follows. So in measurement 1, it is just the basics of measurement. And first of all, we must start by knowing what is measurement. There are things we measure in daily life. We know who is heavier than who because of we measure the two people. We know that this one is a half kilogram of sugar and this one is 1 kilogram of sugar. We know it. Why? Because we have to measure it. So right now, I don't want to take you through many things. I just want to take you through the what I want you to know. As a teacher, there are things I would want you to know, and I know. So now, let's start with the definition of the word measurement. It refers to the process of finding the size of a physical quantity. When you find the length of a distance from Nairobi to Kisumu, that is a process of finding the physical quantity. So length is the physical quantity here, and measurement is the process of finding that length. Scientists all over the world have one international system of units. That is the system international the units. It is a French language, but we call it the SI units. That is the system international. When we bring it back to English, it is simply the international system of units. So, for example, we have very many physical quantities that actually agree on one measurement or one measuring unit. Time, all over the world, we measure it using seconds. Though we have other multiples of time like minutes, hours, but the SI unit, the unit that we can agree all over the world, is seconds. When we are measuring mass, the unit that we agree all over the world is kilogram. We know the other units like grams, tons, but we agree on one unit. That is now we are calling it the SI unit. There are many units, but we agree on one. On each physical quantity, there is one unit that we agree upon. And there is a reason why the scientists all over the world came up with that agreement. And they says, let's now work with this. Let seconds be the unit, SI unit for time. You see? Let meters be the SI unit of length. So the reason why SI unit were established is to avoid confusion among scientists, then to have international uniformity among scientists. You can imagine if each country, each continent, scientists from all over the world are using different units, there will be a confusion all over. So the SI unit is there to avoid the confusion, and the SI unit is there to bring the uniformity amongst the scientists. You are a scientist, I am a scientist. We are united by the SI unit. We have two types of physical quantities. We have the ones which are being measured directly by use of measuring instruments. We call them the basic physical quantities or fundamental physical quantities. Then we have the others that we have to apply calculation in order for them to be obtained. For example, for you to get volume, which is a physical quantity, we have to calculate volume using a given formulas depending on the shape of the object or the container. But we are going to start with the first one, the basic physical quantities, which actually are measured directly. We have 7 of them, and I want to give you a table summarizing the basic physical quantities. The other name, fundamental physical quantities, but the most common name is basic because they are just measured directly. For example, time, length. Now, in this next slide, I can just show you what is going on. We have the 7 of them. We have length, and the SI unit of length is meter. We have the symbol for meter is small m. If you use a capital M, you will be confusing with the molarity. Capital M is meant to be used for molarity in chemistry form 3, not as the symbol for length or for meter, that is. Mass, kilogram, that is kg, small k, small g. Time is seconds to small s. Electric currents, that is the ampere, capital A is the symbol for ampere. Thermodynamic temperature, that is Kelvin, and capital K is the symbol for Kelvin. Luminous intensity, candela is the SI unit, and the symbol for candela is capital C, small d, C, D. Amount of substance, mole, and the symbol for the mole is MOL. These are the 7 basic physical quantities. We measure them. The difference between the derived quantities and the ones and the basic quantities is basic are measured directly by use of measuring instruments. Derived quantities is you have to obtain through multiplications or divisions. For example, volume, density, momentum, such things. Here, I'm just giving you the definition of derived physical quantities. They are quantities obtained by multiplication or division of other physical quantities. For example, area, volume, work, density, momentum. These are have a given formulas that can actually be used to find them. There's an exercise here I want to give you. Identify any mistake or mistakes in the following units, and hence write them correctly. Amperes, you can see how it has been written. Amperes, A, small a. Candela, you have been given as cant. Meters, you've been given capital M. Kelvin, find the mistake there. Seconds, find the mistake there. Kilograms, find the mistake. Pascals, also still find the mistake there. There must be a mistake hidden. Just to look at it very keen, you will notice that there is a mistake. For example, I can do the first one for you. Amperes, the symbol for amperes has been given as small letter O instead of capital letter O. Do the rest as your exercise. Also, you have been given here a table which I want you to fill it. Fill the SI unit, fill the symbol of the unit, then go ahead. For example, length, the derived quantity of length is volume, for example. Area, it's a derived quantity. For mass, we have density, we have momentum. Just try to find out for every of the unit, I mean the basic quantity, what could be the derived quantity that can erupt as a result of that particular basic quantity. Some of them, it may be difficult for somebody who is still in Form 1 because that person has not learned much formulas. But somebody who is in Form 3 can answer this thing very well because you can really state. For example, when we talk about, when we ask you now, we ask you about thermodynamic temperature. What is the derived? The quantity of it is one of them, but now, because most of you have not learned in Form 1, you will know it as you are progressing on. There is a question here which I think we have answered in our previous slide. There are 2 types of physical quantities, basic and derived quantities. State the difference between the two. State the difference between the two. That one we have stated. Then we have another question here. You are told to explain the necessity for the establishment of SI units. Why was there SI units? Why was there SI units? Yes, then now that is the end of the side of the basic physical quantities. But now I want us to discuss them one by one. I've just shown you length, mass. Now I want us to get in, then we discuss one by one. For example, now length. We see what we use to measure length all through. Just slide to the next video and I know you will learn. Let's learn together. Let's achieve the next 150 videos concerning the Form 1 to Form 4